Welcome students for this lecture on rapid prototyping. In this lecture we are going to learn the basic concept of the rapid prototyping, then the different applications of the rapid prototyping and the different methods of the rapid prototyping based on the manufacturing or the basic material which is used in the manufacturing. So in this today's era, the customer demands are increasing very rapidly. Rather, we can say the today's market is the buyer's market instead of the seller's market. If you see in 1990, whatever company is manufacturing, the customer is buying that. So there is no alternative for the customer to buy from the market. So it was the seller's market in the 1990. But today, if you compare the market situation with that, it has changed completely, and the customer has lot of options from the market. You can take the example. If the customer if the customer is purchasing the car from the market, nowadays lot of manufacturing companies are available which is manufacturing the car, and these car manufacturing companies are having variety of models. Okay, so variety of models are available from this car manufacturing company. So this was not the case in the 1990. In 1990, whatever car manufacturing company is giving you, the customer is purchasing it, and there is no alternative for the customer. So this has changed drastically in the today's era. So from the seller's market, it becomes the buyer's market. So what we have to do, we need to satisfy the customer so that the customer should buy the product of your company, of our company. So what we can say, not only from the quality wise but also the cost wise. So both the things will be important for satisfaction of the customer. So if you compare the traditional manufacturing technology, in the traditional manufacturing we are having the steps. As the first you have to go for designing, then you have to go for the manufacturing, after that we have the assembly, and then finally the testing. Okay. So this was the steps in the traditional manufacturing. Now if your testing fails, then what? Then again you have to go for the designing. You have to make some changes in the design, and then we will go again for manufacturing, assembly and testing. So this will continue unless and until you get your final product as per your requirement. So this is your loss of the resources, loss of the time, loss of the money. So ultimately all these losses, whatever you are investing in development of the product, so this will be added in the final cost of your product. So addition in the final cost of the product means what? This will add to the cost to the customer. And if your cost of the manufactured product is more than your competitor, then customer will not buy it, and ultimately the company will suffer. So one has to keep the manufacturing cost minimum, and for keeping this, what we have to do, we have to reduce the cost in the designing, manufacturing, assembly and testing. Okay, so for example, you can take an example of the foundry or the casting. You can see that in the casting, what we are having, your first step is your pattern designing, then after pattern designing you are going for the mold making, ramming of the sand will be there, then you are pouring the molten material for the casting, and then finally the evaluation of the performance. Again, if the performance of the component is not up to the mark, then what will happen? Again you have to go for the pattern design, or you have to change the design of the pattern. So this continues. So this is a very exhaustive process, and this is the wastage of the resources of the company, and ultimately the addition to the cost of the final product. So because of this, we need to look for some new technology. Okay, so to survive in the today's market, we have to go for the new technology. So designing, redesigning until you are getting the satisfactory product. So it is a very slow process and it is a very time consuming process, we can say. So to overcome all these things, we have to go with the new trend, and this new trend is what your rapid manufacturing or rapid prototyping. Okay. In today's era, we can say that the alternative to this one is we are having the rapid manufacturing technology or the rapid prototyping technology. So what we are having in the traditional process, designing, manufacturing, then assembly and testing, so all these will be eliminated and we can get directly the component manufacture very rapidly with the help of this rapid prototyping technology, and we will see how this is possible in the rapid prototyping technology. In this rapid prototyping technology, we are developing a physical model with the help of the special purpose machines. So it is a specialized machining technology. So we have the different special purpose machine as per your manufacturing, and one by one we will see that what are different special machining technologies are available for manufacturing of this component. So basically we have the 3D CAD model. So 3D CAD model you have to develop with the help of the software, and the input from this 3D input to the machine will be given from this 3D CAD model, and we can directly manufacture the component from this 3D CAD data. So whatever software you are using for the 3D CAD, so this software is directly output of this software will be given to the input of this input to the machine. That is a special machining technology. It is called as a rapid prototyping machines. So the input will be given to the machines for manufacturing, and we can manufacture the component from this special machining technology. So it is an additive approach for manufacturing the component. So we can say in the additive approach or in the addition approach, we are using the basic raw material. It may be in the liquid form, it may be in the powder form, or it may be in the solid form. So depending on the material what we are using for the manufacturing, liquid, powder or solid form, we have the different techniques of the rapid prototyping. So rather we can divide the rapid prototyping technique based on the what raw materials we are using for the manufacturing. We will see that in the coming slides. So it is the concept of layer by layer manufacturing. Okay, and we are using the powders of the ceramics, wood, plastic, even metal powders also we are using for manufacturing of the components. Not only the powders but also the liquid material. From the liquid material we can manufacture the component, from the solid material also we can manufacture the rapid prototyping component. So all this is possible in this new technology for the manufacturing. So what is the basic thing? The 3D CAD model data, whatever 3D CAD model you have developed, we can check this 3D CAD model with the help of the software, and after your 3D CAD model is finalized, we can directly give the input to the machines. So we can say it is a very rapid manufacturing. So rapidly 3D CAD model output of the CAD model will be given to the input to the machine, the special purpose machine, and the machine will start manufacturing rapidly. So there is no intermediate stages. So we can see that the basic we are getting manufacturing is very rapid. So making it rapid is the basic concept in the rapid prototyping, and once you manufacture it rapidly, your resources will be saved, your time will be saved. Ultimately the company profit may be increased also. So making it rapid is the basic concept what we are having in the rapid prototyping. Some of the companies are also using this technology for manufacturing the final component. So the component which is manufactured with this technology can be directly used in the actual applications. So it can be directly used in the applications for the use. So this is also the one biggest advantage of this technology. Direct component can be used in the application, and in the coming years this technology is going to occupy the major share in the market. as it offers the attractive advantages for manufacturing. Now let's see some of the applications of the rapid prototyping. Uh, it is used for checking the feasibility of the new design concept. So before introduction of the new design in the market, we are checking the feasibility, whether it is working or not, whether it is satisfying the customer needs, and from different points of view. Once the designer is satisfied, once the company is satisfied, then and then it is introduced in the market. So before introduction in the market, it is a very important step. So feasibility of your design or your manufacturing can be assessed with the help of this model or the component which is developed by the rapid prototyping. And we know it is a very cost effective technology. Even we can directly use the component in the application, and with the help of this component we can conduct the market test also, or we can go for the evaluation also, whether your component is performing accordingly or not. So this can be market test and evaluation can be done with the help of the component, and this offers the advantage directly to the manufacturer. Now in the component, a lot of parts are assembled. Okay. So this assembly of the parts can be easily checked with the help of this rapid prototyping parts, whether you are getting the proper fit or not in case of the complex assembly. So lot of components or parts will get assembled in your final product. So these components will have the fitting of the two parts, and this fit of the parts in the complex mechanism or the assembly can be checked with the help of the parts which are manufactured with the help of the rapid prototyping. And one can get the idea whether your manufacturing, you have to change the manufacturing or you have to change the design for your as per your requirement in the assembly to get the required fit. Then the most important thing is that in the rapid prototyping we can have the concurrent product development. Concurrent is nothing but your simultaneous product development. So we can have the simultaneous product will be developed simultaneously rather than sequential product development. In sequential product development, we have to follow the steps. Step number 1, then step number 2, step number 3, like this. Okay. So we have to follow the steps in the manufacturing in case of the sequential manufacturing. In concurrent manufacturing, we can go for the simultaneously for the different steps. So this rapid prototyping component can promote the concurrent product development, and this will save the time, or this will eliminate the time in the manufacturing. So this is what the advantage of the rapid prototyping technology. Concurrent product development is possible with the help of this rapid prototyping technology. Then we can have the manufacturing of the exact copies simultaneously. So we can manufacture the similar components, or the similar products can be easily manufactured with the help of this rapid prototyping technology. So and with no variation. Okay, so variation will not be there. So we are using the 3D CAD model, and the input of the 3D CAD model will be given to the machine. Okay, and this will be exact copies, we can say similar copies can be there for the component that we are manufacturing with the help of this rapid prototyping. Then it is used for making the molds for the wax cores in the casting. Okay, we know the wax cores we are using in the casting in case of the investment casting. So these molds of the wax cores can be used manufactured with the help of this rapid prototyping. It is used for master for silicon and epoxy molds also. So this is also the case of the casting. In case of silicon and epoxy molds, we can make the masters with the help of this rapid prototyping technology. So this technology is becoming very popular in the industries, and we can say the share of this technology in the manufacturing. So majority of the share will be in the tooling, functional parts, fits, rapid manufacturing. Okay. So it is occupying the majority of the share in the industrial application. Okay, and majority we can see the tooling is using this technology widely for manufacturing. Okay, and The application wise it will grow slowly for all the parts in the industry. Nowadays we can say initially it is used by the designer for checking the feasibility of the design, whether it is working or not, and in some of the application it is used for direct manufacturing of the final component also. So final component can be directly manufactured, and the component can be used in the actual application, and one can assess whether your product is functioning properly or not. So this is what the biggest advantage what we are having with the rapid prototyping technology. If you compare the conventional manufacturing and the rapid manufacturing, we can see the main difference between the conventional and rapid manufacturing. In the conventional machining, we can say it is the method which is produced, it is the method of production by removing the material from the workpiece. So we know that the material from the workpiece is removed in the form of the chips. So when there is a contact between the tool and the workpiece, the material will be removed in the form of the chips, and this is a subtraction process. So you are eliminating the material, or you are removing the material to get your final product. So it is called as a subtraction process. So that's why it is a limited process. But if you see the rapid manufacturing technology, it is a process of addition of the material. So this material will be added layer by layer in the manufacturing. So this is the addition process, and it is unlimited process. We can add the layers. Number of layers can be added as per your requirements. So whatever is the thickness of the layer you are deciding. Okay. So it is the addition process we are having as compared to the subtraction process of the conventional machining. So one layer, once you deposit the one layer, you have to deposit the another layer, then the third layer, like this. So this will continues. So number of layers will be there, and the component can be built by addition of the layer, one layer over the another layer. So this is a layer by layer manufacturing we are having, and it is an addition process in comparison with the subtraction process of your conventional manufacturing. Now let's see some of the important steps in the rapid prototyping. We can see that in the rapid prototyping we have the how this rapid prototyping component can be manufactured. A CAD model is constructed, and then this CAD model, what we are constructing this CAD model, so we may use any software for construction of this CAD model. Okay. So this CAD model we are constructing with the help of this software, and nowadays we have variety of these softwares available for construction of this 3D CAD model. Then conversion of this CAD model will be done into the standard triangular language format, that is called as the STL format. So this CAD model will be saved in this STL format. That is the conversion of the CAD model into the STL format. That is the second step. Then third one, slicing of this STL file into the thin sections. So this STL file will be sliced into the thin sections. This will be your third step. And then building the part layer by the actual your special purpose rapid manufacturing device. Okay. So layer by layer manufacturing will be there, and what will be your thickness of the layer, that you have to decide. So smaller the thickness, more will be the number of layers. Larger the thickness, less will be the number of layers in the rapid manufacturing technology. Then finally you have to go for the post processing, finishing or joining. So any chips, burrs or extra material is there, so you have to remove these with the help of this post processing or finishing process. Okay. So this is what the steps in the rapid prototyping or the rapid manufacturing. First you create the CAD model, then convert the CAD model into the STL file, that is the standard triangular language format. Then slicing of this file into the thin section, STL file is sliced into the thin sections. Then you have to build the parts layer by layer, that is actual manufacturing will be there. That is what your deposition of the one layer over the another layer. And then finally the post processing, finishing and or joining we are having for your component. So you can see how this workflow will be there, that is shown here in this figure. So to develop the CAD model, we have the 3D CAD model which has been developed with the help of the software which is available. Then we have to go for the pre-processing. In the pre-processing, we have to generate the STL file. That is your standard triangular language file that is generated from the 3D CAD model. So you have to save this 3D CAD model in the STL file format. You have to build the supports if needed. Then the slicing will be done in the STL file. Okay, so this is your pre-processing will be there before actual manufacturing. And then third one is actual manufacturing, that is the RP process. So we are building the prototype or we are building the model. So this model will be built with the help of your special manufacturing machines. So we have the variety of techniques which are available for manufacturing of this rapid prototyping process. So we can use any of the process as per the requirement for this building the prototype. And then finally the post processing. In the post processing, you have to remove the extra material, you have to remove the supports that is given earlier. Cleaning of the surface will be there, post curing. Okay, so all these things will be there which is required for the final finishing of the component. So this is what the workflow we have in the process of the rapid prototyping. So this is what in this figure we can see here the concept of layer by layer manufacturing. In the figure A, it is a 3D CAD model which is generated with the help of the software. Computer software is used for generation of this 3D CAD model. So this 3D CAD model in the second step is sliced into the layers. Okay. So how much layers we are going to have, that is to be decided. More the layers, then more time it will take for manufacturing, but accuracy will be more or the quality will be better. And less the layer, then less time it will take for manufacturing, but quality wise or accuracy wise it will not be that much satisfactory. Then the third one you can see how the component is built. So we have the support at the bottom, and then on this bottom we are depositing the layer, one layer over the another layer. So we can see here the deposition of the layer one above the another. So this layer deposition will be there one above the another. So in this way the concept of rapid prototyping is developed. How you are manufacturing the rapid prototyping by layer manufacturing, that is shown here with the help of this figure. So computer model is sliced into the layers, number of layers you have to decide, and then after that it depends, number of layers will depends on the thickness, what thickness we are having. So smaller the thickness of the layer, more will be the layers, and lesser the thickness, more the thickness of the layer, then number of layers will decrease. Then the third one you can see how the layers will be deposited one above the another, that is shown here. So this figure shows the concept of your layer by layer manufacturing. Now let's see some of the types of rapid prototyping. So based on your raw material what we are using, whether you are using the liquid as a raw material, solid as a raw material, or the powder based as a raw material. You can see here in the liquid based material, we are using the liquid as the initial material in the manufacturing. So this process requires the curing for the liquid so that liquid is converted into the solid process. In the solid based techniques we are using the some solid material for manufacturing. Okay, so solid can be the shape of the form of the wire, it may be the roll, it may be the laminates or the pallets which are used for the initial material. Then we are using the powder. The material is in the powder form. It may be the powder of the wood, it may be the powder of the plastic, it may be the metal powder also that we are using in the manufacturing. So based on this we can have these different types of rapid prototyping. So here we can see that based on the initial material we have the different categories of the rapid prototyping process. So in the liquid process we have the stereolithography. So it is the photopolymerization process. We will see that. Then solid based curing is there. So it is again the photopolymerization process. FDM process, that is the fused deposition modeling. The solidification will be done by the cooling process. Okay, so we are using the polymer material in this one. Then we have the ballistic particle manufacturing. So solidification is again done by the cooling process. Polymer wax will be there. So all these are the liquid rapid prototyping processes. Then we have the powder. Powder form we are using in the 3-dimensional printing, that is called as the 3D printing, and selective laser sintering. So in this case we are using the powder form, and this powder form we have to deposit the powder one above the another, and then we are adding some binder material in the powder also. So this we will see in the actual process. Then solid process we are having the laminated object manufacturing. So we are depositing the sheet material one above the another. Okay, so paper we may be using the paper, we may be using the polymer for as a solid material. So this is what we have the different rapid manufacturing technology, and as per the application or as per the requirement we can go with the liquid, powder or solid based technology. So students, today we have seen the basics of the rapid prototyping technology, then how the rapid manufacturing concept is implemented in manufacturing of the prototype or the model, then the different applications we have seen for the rapid prototyping, and finally we have seen the basic what basic material we are using, that is liquid material, powder material or solid material for rapid prototyping. So thank you.